And I'm delighted to present to you Rajesh Gangam for this webinar today. Rajesh is a senior principal engineer at Palo Alto Networks. I've known Rajesh now for many years. One of my favorite customers today at Palo Alto Networks, and before that, when he was at Cisco. And I know that Rajesh has been using advanced debugging tooling for a long time. And I think the content today, what you're going to see is he's going to take you through real world how to track down issues in the FRR stack, and going to use the tooling that's available. And I think, you cannot be a great programmer without also being great at debugging, right? Debugging and just understanding the code base is a fundamental part of being a programmer. And you can't be great at debugging if you don't know how to use the tools that are available. And Rajesh is one of the experts in this. He's been using advanced tooling like time travel debugging for really many years, right? Since it was right at the very beginning. So yeah, I'm really looking forward to what he's got to show us. I've seen a little bit of a sneak preview and I know it's really good. And while we're talking, please do everyone ask questions you might have in the chat. And we'll try to answer and address questions along the way. We might not get a chance to get to all of them, but if we don't, then we can follow up and do that. So yeah, please do contribute in the chat, make it interactive. And then with that, I'm going to hand over to Rajesh.
Thank you, Greg, for the warm welcome. Hi, everybody. Good afternoon, good morning, good evening as well, right? So let me share my screen first. So today I'm going to talk about, using different debugging tools that you can use to debug third-party code. I may have a demo with using FRR today, but then I have used this tool, it should applicable for any other open source tool, as long as, it is running in Linux, right? So who is this, the PPT or the presentation that we are having, it is targeted for, it's selected for a young developer, for an experienced, as well as, companies or the managers, right? So as a young developer, you can, start understanding the code day in, very immediately. As a young experienced developer, you can own the issue right now immediately because you have all the tools that are needed to debug the problem. There is nobody else is going to help, right? Because it's third party. And as a software company, let's assume you are the first person to see the vulnerability, and you need all the tooling mechanism available to be able to debug certain pieces of code that you are actually shipping. Okay, so given that, I'm going to use FRR as a open source third party tool today to be able to demonstrate this debugging techniques and to say what is FRR in a small nutshell. It is actually being used at a lot of places. It runs on embedded devices and big servers you probably know Sonic, and you probably know all Viato all it crosses across a lot of machines, right? And one of the protocols are the PGP and OSPF that we really use. So today, before we go that way, I wanted to give you an example issue, right? Let's say you are a developer and you are seeing a problem, right? What is the first thing that you do? You want to check if this issue exists in open source or not, right? So there are a similar issue that I've seen before, where I was trying to program static routes of 100K, okay? And I have experienced that, for the 100K routes, it actually takes more than 24 hours to install them. So when I did a background search, I was able to find out this ticket, which actually talks about, 10K routes in FRR is very, very slow over time, right? So at initial it is fast, and later on it becomes slow, right? Then when I researched it, and I see that the bug is still in open state, and then I felt like, this may be a good, way to, if it is open, then it is my chance to work on it. So then I I see what are the comments that are available on the ticket. Okay, it has not been addressed at the speed at which we were looking at. The and then there was a patch that was suggested, and then that patch was not really helpful for me because it was actually asking me to do a no northbound, but then I needed a mechanism to do northbound, that is basically a gRPC channel to send all the static routes in. And the patch that was shared was also on the latest branch, but I was still using an older branch, right? And also I have some changes that are not there in the open source community, probably, additional debugs and stuff like that, right? So, but I'm sure, Sonic has many more patches that, that are not there in mainline FRR, in which case what happens is your patch may not be directly applicable. That makes it difficult for you to debug on the get-go. Okay, so today I'm going to talk about two tools. Like one of them is this time travel debugging. One of the time travel debuggers that is open source is RR. And as an FRR engineer, record and replay technique is not a something that you are suddenly getting introduced to. It's actually being used. It's actually being documented well. So yeah, and it works really well, right? So before I go into what the tools, let me create a what we are trying to check. Here we are trying to check. Here we have a static route that we are trying to install, 10K or 100K static routes via a gRPC channel or a CLI interface. Now this static T will generate the routes or the FIP routes to Zebra, and the Zebra is going to install them in your kernel or FPM. Okay. Now, as a first job, we have to figure out when these 100K routes are being pumped in. You don't know anything. You're starting afresh, and you're like naive user into this one. You have to know where is the bottleneck, right? So the first tool that I'm gonna make my setup ready. I'm gonna pump in 10,000 routes through this small snippet. Okay. Then I do the experiment just by pumping out the signal. Then I see the issue. I was able to reproduce the issue, and I can clearly see that for 10,000 routes it took me close to 1. Mind you, this was an experiment done long ago where it was using an older Lipiang version. Maybe with the latest Lipiang, it might be little performance is better, but then it's still slower, right? So then I saw that, so at the end, if you see right, the 1,000 routes is taking 60 seconds. But if you want to pump, 10,000 routes, probably under 10 seconds is what I was looking for. Maybe not 10 seconds, at least 20 seconds, right? The reason why I'm looking at that high rate is like if you are crashing or restarting, we need to be able to recover very fast, right? And I know for a fact that, recovery on static routes it has no issues. But then the problem is some clients can go in and come out and it becomes a little slower. So that is why we need this problem to be solved. Then first thing I did is running a flame graph. What is a flame graph? It is just a JavaScript tool based out of perf data. So what I did was I ran a perf analysis on this process called static T. Then when I recreated the issue, I can actually see the flame graph telling lot of Lipiang calls, as you can see. That is when I realized that, okay, Lipiang has a problem. When I went into the ticket again, I saw that this problem, it's already being addressed that, you need to have the greatest and latest Lipiang. So I tried to get the latest and greatest Lipiang. It's still did not. Okay. And then what you need to do next, right? Like, okay, you are able to do the flame graph. You know that, processing Lipiang through static routes is difficult. Then you need to come up with an approach where you come up with the different solutions, try to figure out different methods you can solve, right? After a lot of thought, I thought of not using Lipiang altogether. Okay. This is because, Lipiang as a definition is a text processing tool. text process tools are actually, quite slow, and I don't think it will change any further in next decade as well, right? It's going to be slower. So the PI usage for a high performance problem is never going to work. So at that instant, I decided that, we need to transfer the information of all the static routes in a binary format so that I can, mix and match, and then able to derive what libyan used to do. There might be some disadvantages, like, I may have to reinterface like multiple APIs which was earlier using libyan. Um, and then, yeah, I may not get all the benefits that, the libyan was to the beginning. But then at my thing, like, I needed a use case where I need to be able to come 100K routes, but I don't need all the features that, the libyan is providing. That is where I decided we need to shortcut the libyan calls. Okay. So these are I'm going to go through a demo where I'm going to show you the problem. Then I'm going to show you the problem where I've done the fix, where I was able to shortcut those. So in this demo, I'm going to show you the routes. Then I'm going to do the recording. Then I'm going to go, the only function of interest right now is equal route send, and that is the interface that we are sending the route to Zebra. Okay, then I'm going to show how to use tool mode, flame graph, and then, and then see how the fix is working at the end. Okay, so let me jump to my demo screen. Okay, here I have 3 terminals, and here I have 3 terminals. The first terminal is my VTY shell, and my second terminal would be this is my second terminal to be, script to add routes, and third one would be to collect tickets. Okay, the fourth one is to collect the frame graph onto the desktop. Okay. So let's see if we are running static T right now. So I'm going to check. And static T is already running. So let us log into the terminal. So let's see if there are any static routes already there. I have run some static routes. About 800 static routes are already being added. So static routes, okay, I have some static routes installed already. Okay. So now I will go to the script that I have now mentioned before, which is called add routes.py. For the demo purpose, earlier it had 10,000 routes. Now I'm going to change it to maybe some routes. Okay. So assuming that you already done the flame graph, so I'm going to first do what is called live record. Okay. The same technique is available in Mozilla RR also. It's called RR record. The interface is the same. Okay. Let's do it. So the static fetch the static T process ID. I'm going to say live record minus P 292. Okay. Just a permission issue. Okay. Okay. So it is doing a recording right now. It is a unlike many applications, recording FRR processes is a light overhead implementation. So you can record longer hours, without having to go. think of the disk storage or the RAM and the event logger available. Okay. So while this is happening, I'm going to go here. I'm going to execute this script. So some scripts, some static routes are getting added. Okay, we can see here. So when we are seeing, right, we can see that the static routes are getting added. So in 1 second, you can see about 6 routes were added, right? It's quite slow, and of course, it is slow because it is coming through a CLI interface. But you can see it's not great, configuring through CLI. But then the backend information is the same, right? So then I go to this. I stopped doing. I am going to stop the recording, right? So what I did was all the process that was executed and all the events that I have been executing have been saved in this file. I only have to run this interface to this file, and I will be able to have a GDB interface to this code. Wow. I have I don't have the process running, but I have a GDB interface for which I can go to the end. It's taking slow. While it is going, let me fetch the GDB function name that I was talking about. It's called gclient. See? Let me go to the beginning of the recording first. I'm going to put a breakpoint, just like a GDB. And let's say what is happening. Oh, it hit, this is the time, let's say, you can see that it has passed some time and it is able to get a CPU counter. And I was seeing the to in mode, which function it is calling. Okay, it is being called, send is being called. It is trying to send a message to Zebra. Okay. This is something that I knew before. Not everybody. In that case, what happens is that you need to run some additional tracing to figure out functions of interest or get the functions of interest from the flame graph, right? So let's see what's happening. So I'm calling zclient route send, and it is being, and let's see the first function that's being called. Oh, it's fairly deep call stack, which would have taken forever to figure out if I was doing it myself. I can see that there is a thing called FVTY that is being called, and then I can see that the IP route is being passed here. I can see here all the arguments that have been passed are here fairly available. Then I can see the YARN format that is being displayed. That is when I closely look into the stack. I can see that the northbound CLI.c is the one that is using all the YARN API. As I discussed, we need to do a shortcut. You don't have to call the Lipiang API to program a static route. So I decided, hey, how can I call static.nbrun to call some API which will do the exact same thing and which eventually can call static next hop, right? And it will be very high performance, right? So before that, I needed to know what are the parameters that are being run. So let's go to the frame. See the room. I don't know which one. More on import. Oh, so I want to go to this function. I can actually can print code, and I can see the code. I can clearly see that this function is very small. It only needs to build the next stop. You pass in the args, and then you build the next stop, and that is all is required to build the static install next stop, right? So that is good news. Then I wanted to go backtrace, and I wanted to see what was the initial call that was calling. Okay. So the fulfills break this one, and I'm going to do what we call it as reverse continue, which is reverse of using continue in GDB. I can see that the NB run, and I can see that the arguments that are passed here, and then only thing that I need is what we are building and then sending it to the Lipiang, right? So once I have identified all these things, I would have written the function that would do the exact same thing as the libyan call was doing. So for this thing, I'm going to go to the new terminal where I have my fix running. For the time being, I've done my recordings already. So I have I'm going to take the latest one. Okay, I had done some debugging before. So it was able to show me all the previous debugs from its history. And I'm at the same point as before. But when I'm going to do PT, I can actually see that, the NB run that earlier it was calling the Libyang APIs, it is only calling my function route install. And it built all the things that are required to be able to install static route in TK. Now I can use the tool mode again and then go into frame 4 and you can see my code that we have written to enable all this processing, right? This is, imagine, we have never published any source code onto any bug fix onto FRR before, and we were able to do this important change with just small tools like flame graph and record replay, and then you can achieve such a big thing is tremendous, right? And imagine people are worried about 10K routes, we are able to achieve 100K routes, and that's phenomenal, right? So since we know we have done it, let's go jump back into this, right? I know I have used time travel debugging. I have used it such a long time that it was my LLM before LLM existed, right? And I also have been a great proponent of telling it to teams that it has become a norm to actually to cross communicate with the team members, even if it is remote. It's a way better way to share the problem than writing multiple lines of text and then not being able to tell the problem properly. Uh, so that's how I'm been using it for a long time. Now, given that this is happening, you will become more and more, reliant on these tools to be a better developer by becoming more understanding of the system, and then you will be able to innovate much faster than you now think, right? So eventually, I think these tools are gonna make you even improve cache. It can go until CPU, which is not. I think that may one day very well happen, right? In a conclusion, what I was trying to show you was, the tools are very powerful. It can show you the bottlenecks. You can see the events, and then you can go back and forth and then able to debug very well. So after this, you should learn these tools, and then you should not be fear of. You should be able to debug any third-party code without any fear. And that's all I have today, and I hope this is helpful to you. You can take some questions of the time.
But thank you very much for that, Rajesh. We covered a lot of stuff there. There's a lot of detail very, very quickly. But so yeah, we've got some questions coming in now that we can spend a bit of time on. So first one in. So how come you used Undo rather than RR, which of course is open source and very kind of available?
Well, like one of the technique that I'm really like is RR requires recording from the beginning, and my company sponsored it. So and I took advantage of able to attach it to the process directly at any point of its instance. Yes, and not that no, Undo can also do recording from beginning. So it's always helpful when you you can have smaller recordings. If you attach the process at the start and at the time you want.
So and can you talk a bit about, presumably there's a fair bit of overhead in creating these recordings. Like what kind of slowdown do you see the program running at, and what kind of memory and disk space is needed?
So the events are all in the RAM. What you actually need is extra RAM. If you are running on a server-based system, it is fine. The problem is when you are running this in embedded system, okay, where you may not have that much memory available. So that is where, again, the previous point, where attaching it directly to the process will be helpful. So the second point was the overhead. Yes, it was under my this one. This is not the only process that I work on, right? So I have other processes where there are certain limitations. It takes a lot of events that are being recorded, but the simple implementations, that are fairly basically Unix applications which are very light threaded, and there is not much overhead.
Yeah. And question coming here from Satish Kumar Chamana. So when you fix your code, and do you find the previous recording, can you use the previous recording against your fixed code, or do you need to create a new recording?
The recording binary is for the instance of snapshot, so you cannot use the same one.
Right. So you can't sort of make a fix and then rerun that recording to see. Yeah. So I think what the question is, like, can I make a fix and then verify it against a recording? And the answer is no. You have to, a recording is inherently attached to a particular application binary. Yeah. Although I guess you can, you can kind of do one thing you can do, and I don't know if you've done this, but I've certainly seen this done, is a side-by-side comparison. So I've got a recording of when the program was behaving, and another recording of when it was like misbehaving. Maybe it's like 1 in 1,000 kind of failure, and now I can see kind of side by side the difference.
I use similar technique to compare again different versions of FRR.
Right. Okay. Yeah. So like if there's a regression or a change and you want to understand,
yes,
I've got these different results. What's the root cause?
Where it actually diverges.
Yeah.
That's where it's going to help me. Yeah, I can just go next on both the timers at the same time, and then I can do next. And after it diverges, I will get to.
I think that's a really good point, actually. I think in general, when you're debugging or root causing or whatever an issue, then what you're looking for is, where is that point in history where reality diverged from my expectations? And you showed a couple of tools today that I think are great examples of that, right? So one was the time travel. The other thing you showed was the flame graph. Flame graph is very useful. This is a famous thing for programming. Like, we have expectations about where our program is going to spend all its time, and they're like always wrong, right? Our expectations as humans, we're just really bad at predicting where is all the time going to get spent. And so taking that flame graph approach lets you see what's reality versus what's my expectation.
It's more like, in-depth view, like 100-degree view.
Yeah, exactly. So flame graph gives you the really nice high level overview, and then you can kind of zoom in and take the kind of microscope view to what's going on. And then another question in on the chat: how much memory requirements and runtime requirements bump up with and without the recording? So we kind of touched on this a bit before. I mean, I can maybe try and answer that if that's okay, because I've we obviously worked with many different customers across different companies and different kind of industries and things, so kind of get perhaps a more kind of a broader view. The general, honestly, the answer is that it does depend a lot, right? Different applications will exhibit different kind of behaviors, but the general kind of parameters that I give when I get asked this question a lot is 2x the runtime and 2x the memory. Now, that will vary. Sometimes it's 1.5x and sometimes it's 4x, but that kind of gives you a sense, right? So it's not like, so the point is, it's not like a few percent, right? So you wouldn't like turn on the recording all the time, just in case. Like you need to turn on this is when you're zooming in, like you said, you're zooming in on a particular issue, and I can take a reproduce, but so it's not like a few percent you're going to leave it on all the time, just in case. It's also not like 100x, like a Valgrind kind of thing where it's just impractical to deploy this on on a real system. So you can deploy it in production. You can certainly deploy it in kind of test and stress test environments, but you turn it on when you need it.